Okay, here's the video on the Pythagorean Theorem again, part 2. So let's go over the formula. Remember, it's a squared plus b squared equals c squared, and you know another way of doing it. C squared equals what? A squared plus b squared, right? So it doesn't matter which way, but there's also the square root of a squared plus b squared equals c. So that's our equations. Okay, so in this video, we're just going to go over some applications of the Pythagorean theorem. So here we have, let's say we had a telephone pole, and the telephone pole was 22 feet. So I'll write 22 feet here, from 22 feet to this point. And let's say that they were anchoring the pole so it doesn't fall. We have this anchor line, and that's 25 feet. So we have a right triangle here. So we're looking for this. What is that size? So again, we can say that this is A or B, and we can say that's C. It really doesn't matter what letter you use, but most of the time, most people just say that's A, that's B, and that's C, but it really doesn't matter. So now we have to find B. See if you can find that. Find the answer for the length of B. Okay, so let's write the formula. So we have A squared, bring that down, A squared plus B squared, we know equals C squared, or you can use the other method. And we already know that A is 22, so this has to be 22 squared. We don't know what B squared is. That's what we're trying to find. And we know that C squared is 25. Okay, 25 squared. Right? So, what else do we do? Okay, so I'll use a different marker. So we have 22 squared, so 22 times 22, so we have 484. Plus b squared equals 25 squared, which is 25 times 25, 625. Right? What's next? Just do algebra. Minus the 484 on that side, and it cancels. Right? So whatever you do to one side, don't forget to do to the other side. Now you have b squared equals 141. So if b squared is 141, b is the square root of 141. You can just leave that on a test. And we know that the square root of 141 is not a perfect square. The closest perfect square is 144, which would make this 12. So b is about 11.8, because it's very close to 12. You could say 11.8, 11.87 maybe. So it's approximately 11.87. And you can keep going with that, but we know it's irrational. Okay, another problem. Here we have a baseball field, or a softball field. And it says, how far will the softball travel if the girls throw the ball around? Right, so let's say from home, here's home plate, to second base. See, we can make a right triangle. We know it's a right triangle, right, because a baseball diamond, they call it a diamond. It's actually a square. And so we have a 90-degree angle. So here's our hypotenuse right here. Right? So we can, if we turn it like this, you can see it. So, how far will the softball travel from home to second base? So, figure that one out. Okay, so again, we have a squared plus b squared equals c squared. We have a and b and c. Again, it doesn't matter which one was A or B. And we have, now, you have 60 feet, or you can just say 6 feet too. You can get rid of the 0 and then add it later. But you know that 6 squared is 36, so 60 would be 3,600 plus 3,600, and that'll give us 7,200. That's what c squared is, 7,200. We don't want c squared. Remember, we want c, so the square root of 7,200 is our answer, which again will be roughly 84.885, roughly around that. Okay, so here's the final thing we're looking at here. This is just a simpler proof. If you see A, B, and C in this right triangle, we know that the square of A squared, plus the square of b, those both areas will equal the square of c. So that's really a simple proof. We're going to do proofs later in the year, and they'll be more complicated than that. But this was just a simple one. As you can see, if a was 3, then we have 3 squared is 9, and if b was 4, we have 16, and 9 plus 16 is 25. That's the area of the square, and so you would know that would be 5, the 3, 4, 5 triangle. Okay, those are applications of the Pythagorean theorem. The next video we'll talk about the converse of the Pythagorean theorem. Great job.